Now, in this lecture, we'll find out the area of the green shape. In the drawing, we have a quarter circle. A or B is a quarter circle. And we also have here tangent QP, that is tangent to this quarter circle here at this point. Line segment BQ equals to 3 units in its length. Line segment AP equals to 6 units. This is angle BQP, that is a right angle, and this is angle APQ. This is also equals to 90 degrees. Again, our mission is to find out the area of this green shape. So first of all, we define the point of tendency of tangent QP with this quarter circle at this point as point S. And we join points O and S together by a straight line. So, what is the definition of line segment OS? Line segment OS starts from point O, that is the center of the quarter circle, and ends at point S, that is a point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, OS is the radius of this quarter circle. So we define the radius of the quarter circle as X. X is the radius of the quarter circle, so OS is the radius of this quarter circle, therefore it is equal to X. We can implement here rule 1. The radius OS is drawn to point S, that is the point of tendency of tangent QP with this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent QP will be perpendicular to the radius SO. If QP is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. In the next step, we will do a construction, that is to say from point B, we draw perpendicular on OS. Again, from point B, we draw perpendicular on OS. We define the touching point of the perpendicular from point B and OS as point M. By doing this construction, we actually created here quadrilateral BMSQ. Again, from point B, we draw perpendicular on OS, therefore this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. So inside the small quadrilateral BMSQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of this fourth angle, the fourth missing angle. In total, the sum of those 4 angles, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here, the missing fourth angle here, must be equal to 90 degrees in its size. So inside the small quadrilateral BMSQ, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this small quadrilateral BMSQ that has 4 right angles as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle BMSQ, side BQ equals to side MS. BQ equals to MS, but BQ equals to 3, therefore MS also equals to 3 units in its length. MS equals to 3 units. We also have the rule that the opposite sides of a rectangle are parallel to each other. So in rectangle BMSQ, side BM must be parallel to the opposite side MS. So I write it down. In rectangle BMQS, side BQ must be parallel to the opposite side MS. Repeat again. Rectangle BMQS, side BQ must be parallel to the opposite side MS. Side MS, this side MS is part of OS. Again, MS is part of OS. OS is the radius of the quarter circle. OS is a radius, it is absolutely a straight line. So OS is a straight line. MS is part of the straight line OS. Again, MS is part of the straight line OS. And we found out that MS is parallel to BQ. Therefore, OS must be also parallel to BQ. Therefore, OS, the straight line OS, must be also parallel to BQ. According to the rule that if part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Here MS, that is part of the straight line OS, is parallel to BQ, therefore the straight line OS itself must be also parallel to BQ. So OS is parallel to BQ. So in this quadrilateral OBQS, we have side OS that is parallel to BQ. Therefore, quadrilateral OBQS is a trapezoid. So write it down. Quadrilateral OBQS is a trapezoid. Actually, a trapezoid is a quadrilateral with one pair of parallel sides. And quadrilateral BOSQ, this quadrilateral has one pair of parallel sides. That is to say, side OS is parallel to the opposite side BQ. Therefore, BOSQ, quadrilateral BOSQ, is a trapezoid. what is the length of line segment OM? From the drawing it is very easy to see that OM equals to OS minus MS. Again, OS minus MS equals to OM. So I write it down. OM equals to OS minus MS. So OM equals to OS. OS is the radius of the quarter circle that is equal to X according to our definition, minus MS. We just trying to find out that MS equals to 3. So in total, OM equals to X minus 3 units in its length. OM equals to X minus 3 units. So this 9 segment OM is equals to X minus 3 units in its length. In the next step, we will do another construction. That is to say, from point A, we will do perpendicular on OS. Again, from point A, we will do perpendicular on OS. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and OS as N. So inside quadrilateral ANSP, inside this quadrilateral ANSP, we have 1, 2, 3 right angles. Therefore, this fourth angle must be also equal to 90 degrees in its size, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral ANSP we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle in front is closed, so we will relate to this quadrilateral ANSP as a rectangle. And you know that the opposite sides of a rectangle are equal to each other. That is to say, a rectangle in ANSP, side AP equals to the opposite side NS. AP equals to NS, but AP equals to 6, therefore NS must be also equal to 6 units in its length. So I write it down. Side NS is equals to 6 units in its length. And we also have the rule that the opposite sides of a rectangle are parallel to each other. So in rectangle ANSP, side AP is parallel to side NS. AP is parallel to the opposite side NS. Repeat again. In rectangle ANSP, side AP is parallel to the opposite side NS. AP is parallel to NS. But NS, this side NS is part of the straight line OS. Again, NS is part of the straight line OS. And we know that if part of a straight line is parallel to other straight line, then the straight line itself must be also parallel to the other straight line. Therefore, OS must be also parallel to AP. So I write it down. OS is also parallel to the opposite side AP. So this quadrilateral OAPS, side OS is parallel to side AP, therefore quadrilateral OAPS is a trapezoid. Why? Because it has one pair of parallel sides. Side OS is parallel to side AP. So I write it down. Quadrilateral OAPS is a trapezoid because it has one pair of parallel sides. Side OS is parallel to the opposite side AP. So quadrilateral OAPS is a trapezoid. In conclusion, we found out that quadrilateral OBQS is a trapezoid, and also quadrilateral OSPA is also a trapezoid. So the sum of the areas of those two trapezoids will give us the area of the whole shape. The area of the whole shape OAPQB. Again, the sum of the areas of those two trapezoids, trapezoid OBQS plus the area of trapezoid OAPS, will give us the area of this whole shape. Trapezoid, whole shape, shape OAPSQB. Okay? And what is the length of this line segment? Line segment ON. From the drawing, it is very easy to see that ON equals to OS minus NS. Again, OS minus NS equals to ON. So I write it down. The length of this line segment ON is equals to OS minus NS. So ON equals to OS, that is the radius of the quarter circle, that is equal to X, minus NS. We just write down for that NS equals to 6. Here NS equals to 6. So in conclusion, we found out that ON in total is equal to X minus 6 units in its length. This line segment ON is equals to X minus 6 units in its length. In the next step, we will focus on the right triangle A and O. On this right triangle A and O, we will define this angle, this actual angle NOA, as alpha. So in this right triangle ONA, this angle equals to alpha, this angle equals to 90 degrees, therefore this missing angle must be equal to 90 degrees minus alpha. According to the rule that the sum of the angles in the triangle is equal to 180 degrees. So the missing angle must be equal to 90 degrees minus alpha. We will define 90 degrees minus alpha as beta. Therefore, the missing angle must be equal to beta according to our definition. If 90 degrees minus alpha equals to beta, it means that 90 degrees minus beta will be equal to alpha. Why? Because if you add to this equation alpha and then subtract beta, you will get that 90 degrees minus beta equals to alpha. Okay? So, we know that angle BOA, this angle BOA is a right angle, it is equal to 90 degrees according to what is given as the question. Why? Because shape BOA is a quarter circle. Therefore, angle BOA is a right angle. This angle equals to 90 degrees in its size. So angle BOA, that is a right angle, is equal to 90 degrees minus this angle alpha must be equal to the missing angle BOM. To this missing angle BOM. So angle BOA, that is equal to 90 degrees minus angle alpha equals to this angle. So this angle, the missing angle, equals to 90 degrees minus alpha. And according to our definition, 90 degrees minus alpha equals to beta, so the missing angle here equals to beta. In the next step, we'll focus on the right triangle OBM. In this right triangle OBM, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But we have already found out that 90 degrees minus beta equals to alpha. So we can write here that this, the missing angle here, is equal to 90 degrees minus beta, it is equals to alpha. According to this formula, that 90 degrees minus beta equals to alpha. So in the next step, we will prove that the right triangle OBM is congruent to the right triangle ONA. Again, we prove that the right triangle OBM is congruent to the right triangle ONA. So I write it down. The right triangle OBM is congruent to the right triangle ONA. So why those two right triangles can work to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle OMB in the right triangle OMB, and it is equal to this angle, that is actually angle ONA in the right triangle ONA. So, I'll repeat again, I found out actually that angle OMB in the right triangle OBM equals to angle ONA in the right triangle ONA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, those two angles, they are both equal to alpha, therefore they are equal to each other. So this is angle OBM in the right triangle OBM, and it is equal to this angle, that is actually angle AON in the right triangle ONA. Repeat again, angle OBM in the right triangle OBM equals to angle AON in the right triangle ONA. They are both equal to alpha, therefore they are equal to each other. Those two angles, they are both equal to beta, therefore they are equal to each other. So this is angle BOM in the right triangle OBM, and it is equal to this angle, that is actually angle OAN in the right triangle ONA. Repeat again. Angle BOM in the right triangle OBM equals to angle OAN in the right triangle ONA. They are both equal to beta, therefore they are equal to each other. And finally, side OA in the right triangle OAN is equal to side OB in the right triangle OBM. Those two sides, they are both the radii of the circle, therefore they are equal to each other. They are both the radii of the circle, is equal to x, therefore they are equal to each other. Line segment OA starts from point O, that is the center of the quarter circle, and ends at point A, that is the point on the quarter circle itself. This is exactly the definition of a radius, therefore OA is the radius of this quarter circle, that is equal to x. Likewise, line segment OB starts from point O, that is the center of the quarter circle, and ends at point B, that is the point on the quarter circle itself. Therefore OB is also the radius of this quarter circle, that is equal to x. Repeat again. Side OB of the right triangle OBM is equal to side OA of the right triangle ONA. They are both the radii of the circle, is equal to x, therefore they are equal to each other. So actually found out that the right triangle OBM congruent, this is the sign of congruent, to the right triangle ONA according to angle side angle rule. So, what is angle side angle rule? Angle side angle rule is that if you prove that the two angles and the side that is included between the two angles in one triangle are correspondingly equal to two angles and the side that is included between those two angles in a second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. And here we proved that those two angles alpha and beta and the side that is included between those two angles, that is side OA in the right triangle OBM, are correspondingly equal to those two angles that are also alpha and beta and the side that is included between those two angles, that is side OB in the right triangle OBM. Therefore those two right angles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side ON of the right triangle ONA is equals to side BM of the right triangle OBM. Repeat again. Side ON equals to side BM. Side ON equals to side BM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two right triangles can go into each other, therefore the two corresponding sides ON and BM must be also equal to each other. But we have already found out that ON, side ON, is equal to x minus 6 units in its length. So we can write here that ON equals to x minus 6 and from this equation x minus 6 equals to ON equals to BM. We will derive that side BM is also equals to x minus 6. Side BM is also equals to x minus 6 units in its length. Here, this is side BM that is equals to x minus 6 units in its length. So, side BM is equals to x minus 6 units in its length. Likewise, because of the fact that those two right triangles can go into each other, we will conclude that side OM in the right triangle OBM is equals to side NA in the right triangle ONA. Repeat again, we will conclude that side ON in the right triangle OBM equals to side NA in the right triangle ONA. According to the sum rule, that corresponding angles and congruent triangles are equal to each other. But we have already found out that OM, this is side OM, that is equal to x minus 3 units in its length. Again, side OM equals to x minus 3 units in its length. So I can write here that OM equals to x minus 3, and from this equation x minus 3 equals to OM equals to NA, we will derive that NA is also equals to x minus 3 units in its length. NA equals to x minus 3 units. So this is side NA that is equals to x minus 3 units in its length. In the next step, I will copy the right triangle ONA, this right triangle ONA in a new page, and we'll implement on this right triangle ONA the Pythagoras theorem. Then again, we'll implement on this right triangle ONA the Pythagoras theorem. So side NA equals to x minus 3 units in its length. We have already found out that side ON equals to x minus 6 units in its length. And finally, the hypotenuse OA equals to x units in its length. It is the radius of this quarter circle, It is the radius of this quarter circle that is equal to x units according to our definition. So this is the right angle ONA that I copied from the original drawing. Here, by PT is the abbreviation for Pythagoras theorem. Actually, according to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right angle is OA, therefore the square of the hypotenuse is OA squared, and it must be equal to ON squared plus NA squared. OA is x, therefore OA squared is x squared. And it is equal to ON squared. ON is x minus 6, therefore ON squared is x minus 6 squared plus NA squared. NA is x minus 3, therefore NA squared is x minus 3 squared. In conclusion, we found out that x squared equals to x minus 6 squared plus x minus 3 squared. Here we'll open the brackets on this side of this equation, and we'll get that x squared equals to x minus 6 squared. X minus 6 squared is x squared plus 6 squared, that is 36, minus 2 times x times 6, that is minus 12x, plus x minus 3 squared. X minus 3 squared equals to x squared plus 3 squared, that is 9, minus 2 times x times 3, that is minus 6x. So here we have x squared on both sides of the equation, therefore x squared will get cancelled. So in this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have 36 plus 9 is 45. Minus 12x minus 6x is minus 18x. Plus x squared. In conclusion, I found out that x squared minus 18x plus 45 equals to 0. I repeat again, we actually found out that x squared minus 18x plus 45 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the general formula, to the following general formula, that x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So in our specific quadratic equation, x squared minus 18x plus 45 equals to 0, the coefficient a is equals to 1, the coefficient b is equals to minus 18, and the coefficient c equals to 45. Now we'll put the data inside this formula for x, and we find out the values of x for our specific quadratic equation. Okay, so according to this general formula, x equals to minus b. B is minus 18, therefore minus b is minus 18, that is plus 18, plus minus square root of b squared. B is minus 18, therefore b squared is minus 18 squared, that is 324, minus 4 times a is 1, so minus 4 times 1 is minus 4, and minus 4 times c, that is 45, so minus 4 times 45 is minus 180, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. In conclusion, found out that x equals to 18 plus minus square root. Inside the root we have 324 minus 180 is 144 divided by 2. So x equals to 18 plus minus the square root of 124 is 12 divided by 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to 18 plus 12 over 2. 18 plus 12 is 30, and 30 over 2 is 15. So according to the first solution, x equals to 15 units in its length. And we have also a second solution that is possible for x. The second solution for x is that x equals to 18 minus 12 over 2. 18 minus 12 is 6, and 6 over 2 is 3. So according to the second solution, x equals to 3 units in its length. But we have already found out that line segment BM, this is line segment BM, that is equal to x minus 6 units in its length. BM equals to x minus 6 in its length, x minus 6 units in its length. BM is a length, and as a length, it must be a positive number. That is to say, x minus 6 must be a positive number. It means that it must be greater than 0. If x minus 6 is greater than 0, it means that x is greater than 6. X must be greater than 6. So if x must be greater than 6, x can never be equal to 3, that is less than 6. Again, if x is greater than 6, it can never be equal to 3, that is less than 6. Therefore, the solution that x equals to 3 is a correct solution. We will cancel this solution, and we left only with the first solution that is possible for x, that x equals to 15. So I write it down. So the only solution that is possible for x, that is x equals to 15 units in its length, that is to say, the radius of this quarter circle x is equal to 15 units in its length. Here x equals to 15, here also x equals to 15. OS is equal to x, it is equal to 15. So BM is equal to QS. In rectangle BM QS, it is equal to x minus 6. X is 15, so x minus 6 is 15 minus 6, that is 9. Here in rectangle ANSP, side AN equals to side SP, and AN equals to x minus 3. That is to say, AN equals to x, that is 15 minus 3. 15 minus 3 is 12. So SP equals to 12 units in its length. And QS equals to 9 units in its length. In the next step, I will present to you the general formula, or the formula for the area of any trapezoid. I'll repeat again that the definition of a trapezoid is a quadrilateral with one pair of parallel sides. Again, a trapezoid is a quadrilateral with one pair of parallel sides. So here we have actually quadrilateral ABCD. This is quadrilateral ABCD. In this quadrilateral ABCD, side AD is parallel to side BC. Therefore, this quadrilateral ABCD has one pair of parallel sides, and therefore quadrilateral ABCD is a trapezoid. The two parallel sides, here side AD is parallel to side BC. Those two sides that are parallel to each other, that is to say AD and BC, are defined as the bases of the trapezoid. So AD is the base, and BC is the second base of trapezoid ABCD. DC creates 90 degrees with the two bases. Therefore, DC is the height to the base. We define the height DC as h, so DC equals to h according to our definition. So the area of this quadrilateral, the area of trapezoid ABCD is equals to the sum of its bases. That is to say, it is AD plus BC times the height to the base. The height is DC, that is h, because it creates 90 degrees with the two bases. This angle equals to 90 degrees, and this angle also equals to 90 degrees. Therefore, the height is DC, that is equal to h according to our definition, divided by 2. In conclusion, found out that the area of any trapezoid is equals to the sum of its bases, in this case is AD plus BC, times the height to the base, that is h, over 2. So the area of any trapezoid equals to the sum of its bases times the height over 2. So, what is the area of this grain shape? The area of the grain shape it is equals to the area of the whole shape OAPSQB minus the area of this quarter circle OAB. Again, the area of the green shape equals to the area of the whole shape OAPSQB minus the area of this quarter circle OAB. But the area of this whole shape equals to the area of trapezoid OASP plus the area of this trapezoid OBOS. Okay? The area it is actually OBQS. So the sum of the areas of those two trapezoids will give us the area of the whole shape, and when we subtract the area of this OAB, the area of the quarter circle OAB from the area of the whole shape, it will give us exactly the area of this green shape. So the area of the green shape equals to the area of this trapezoid OSP, OAPS, the area of trapezoid OAPS plus the area of this trapezoid OBQS repeat again that the sum of the areas of those two trapezoids will give us the area of the whole shape, and the area of the whole shape minus the area of this quarter circle OAB will give us exactly the area of this green shape. That is the area that we are looking for. So the area of this whole shape is equals to the sum of the areas of trapezoid OAPS plus the area of trapezoid OBQS. So the area of the whole shape, this is the sum of those two trapezoids, will give us the area of the whole shape minus the area of the quarter circle AOB will give us the area of the green shape, that is the area that we are looking for. So what is the area of this trapezoid OAPS? The area of this trapezoid OAPS equals to the sum of its bases, that is OS plus AP, times the height to the bases, that is SP. Why it is SP? Because it creates 90 degrees with the bases AP and OS. Divided by 2. Repeat again, the area of trapezoid OAPS equals to OS plus AP, that is the sum of its bases, times the height to the bases, that is SP, over 2, plus the area of trapezoid OBQS. What is the area of this trapezoid OBQS? This equals to the sum of its bases, that is OS plus BQ, times the height to the bases. The height creates 90 degrees with the base, therefore the height is OS, because it creates 90 degrees with those two bases, OS and BQ. So it is times the height OS divided by 2. Repeat again, the area of trapezoid OBQS equals to the sum of its bases, that is OS plus BQ, times the height, that is OS, over 2, minus the area of this quarter circle, OAB. The area of a quarter circle equals to the area of the circle over 4. The radius of this big circle, that can complete this quarter circle to a circle, so the radius of the circle of radius r, the radius of a circle that has the area of a circle with radius r, with radius x is pi x squared. So the area of the circle that is pi x squared over 4 will give us the area of the quarter circle A or B. So the area of the green shape equals to OS. OS equals to x, that is 15, plus AP. AP equals to 6 times SP. SP equals to 12 divided by 2. So in conclusion, found out that the area of trapezoid OAPS equals to 15 plus 6 times 12 over 2. 15 plus 6 is 21 times 12 over 2. 12 over 2 is 6, and 21 times 6 is 126. That is to say, the area of trapezoid OAPS equals to 126 square units. The area of this trapezoid OAPS equals to 126 square units, plus the area of this trapezoid OSQB. The area of trapezoid OSQB equals to OS, that is 15, plus BQ, that is 3, times OS, that is 9, divided by 2. Repeat again. We found out that the area of trapezoid OBQS in total is equals to 15 plus 3, that is the sum of its bases, times the height, that is 9 over 2. 15 plus 3 is 18, 15 plus 3 is 18, and 18 over 2 is 9, and 9 times 9 is 81. So in total, the area of trapezoid OBQS equals to 81 square units, minus the area of the quarter circle OAB. The area of the quarter circle AOB equals to pi x squared over 4. So it is pi, x is 15, therefore x squared is 15 squared, that is 225 over 4. In conclusion, found out that the area of the quarter circle AOB equals to 225 pi over 4. 225 pi over 4 is equals to 176.716 square units. In conclusion, found out that the area of the quarter circle AOB is equals to 176.716 square units. So the sum of the areas of the two trapezoids is 126 plus 81, that is 207. That is to say, the sum of the areas of those two trapezoids, or the area of the whole shape, is equals to 207 square units, minus the area of quarter circle AOB, that is equals to 176.716. So 207 minus 176.176 is equals to 30.285. So in conclusion, found out that the area of the green shape is equals to 30 30.285 square units. Repeat again, we found out that the area of this green shape is equal to 30.285 square units. So in the next step I will summarize the lecture. In this lecture, I found out the area of this green shape. So in the drawing we have a quarter circle, and we also have tangent QP. This is tangent QP, this is tangent to this quarter circle here. Line segment PQ equals to 3 units. Line segment AB equals to 6 units in its length. This is angle BQP that is equal to 90 degrees, and this is angle APQ, that is also a right angle, it is equal to 90 degrees in its size. Again, our mission is to find out the area of this green shape. The area of the green shape. Okay, so in the first step, we defined the point of tendency of tangent QP with this quarter circle, this point as point S. And then we join points O and S together by a straight line. What is the definition of line segment OS? Line segment OS starts from point O, that is the center of the quarter circle, and ends at point S, that is the point of the quarter circle itself. So this is exactly the definition of a radius. So OS is the radius of this quarter circle. We define the radius of this quarter circle as X. Here X is the radius of the quarter circle according to our definition. So OS equals to X, because it is the radius of the quarter circle. We can implement here rule 1. Why? Because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent QP with this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent QS will be perpendicular to the radius SO. If QS is, if tangent QP is perpendicular to SO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule 1. In the next step, from point B, we go perpendicular on OS. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and OS as M. So inside this small quadrangle BMSQ, we have 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of this fourth angle. In total, the sum of those 4 angles inside quadrangle BMQS must be equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. So inside quadrangle BMSQ we have 4 right angles. Any quadrangle that has 4 right angles must be at least a rectangle, if not as close. So we relate to this quadrangle BMSQ as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle BMSQ, side BQ must be equal to side MS. But BQ equals to 3, therefore MS must be also equal to 3 units in its length. And also we know that the opposite sides of a rectangle are parallel to each other. That is to say, side B in rectangle BMSQ, side BQ is parallel to side MS. Repeat again. In rectangle BMQS, side BQ must be parallel to the opposite side MS. So BQ is parallel to MS. OS is the radius of the quarter circle, therefore it is absolutely a straight line. So OS is a straight line. So part of the straight line OS, that is MS, is parallel to BQ, therefore the straight line itself OS must be also parallel to BQ. Again, because of the fact that part of the straight line OS, that is MS, is parallel to BQ, therefore the straight line itself OS must be also parallel to BQ. Okay? From the fact that BQ is parallel to MS, we derive that OS is also parallel to BQ. So OS is parallel to BQ, so in quadrangle OBQS, inside this quadrangle, in this quadrangle OBQS, we have side OS that is parallel to side BQ. Therefore, quadrangle OBQS that has one pair of parallel sides is defined as a trapezoid. It is a trapezoid, because it has one pair of parallel sides. So, quadrangle OBQS is a trapezoid because it has one pair of parallel sides. What is the length of this line segment OM? From the drawing it is very easy to see that OM equals to OS minus MS. Again, OS minus MS equals to OM. OM equals to OS minus MS. OS is the radius of the quarter circle is equal to X according to our definition, minus MS. We have already found out that MS equals to 3. MS is 3. So in conclusion, we found out that OM, the length of this line segment OM, is equal to X minus 3. It is equal to X minus 3, it's in its length. In the next step, we did another construction, that is to say, from point A, we drew perpendicular on OS. Again, from point A, we drew perpendicular on OS. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and OS as N. Okay? So inside this quadrangle ANSP, we have 1, 2, 3 right angles. Therefore, this profile must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So inside this quadrangle ANSP, we have 4 right angles. Any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrangle ANSP as a rectangle because it has 4 right angles. And you know that the opposite sides of a rectangle are equal to each other. That is to say, rectangle ANSP, side AP must be equal to the opposite side NS. But AP equals to 6, therefore NS must be also equal to 6 units inside. NS equals to 6. And we have the rule that the opposite sides of a rectangle are parallel to each other. So in rectangle ANSP, side AP is parallel to side NS. Repeat again. In rectangle ANSP, side AP must be parallel to the opposite side NS. So AP is parallel to NS. So actually NS is part of the straight line OS. Again, NS is part of the straight line OS. So if part of the straight line OS, that is NS, is parallel to AP, then the straight line OS itself must be also parallel to AP. Okay? If part of the straight line OS, that is NS, is parallel to AP, then the straight line itself OS must be also parallel to AP. Okay? So OS must be also parallel to AP, because if part of the straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. So inside this quadrangle OSPA, side OS is parallel to side AP, therefore quadrangle OSPA that has one pair of parallel sides is a trapezoid. repeat again, quadrilateral OASP with one pair of parallel sides is a trapezoid, because this is the definition of a trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. In conclusion, we found out that OSPA is a trapezoid and OBQS is also a trapezoid. So the sum of the areas of those two trapezoids will give us the area of the whole shape. Okay, again, the sum of the areas of those two trapezoids will give us the area of this whole shape. Actually, this whole shape consists of those two trapezoids, trapezoid OSPA and trapezoid OBQS. Therefore, the sum of the areas of the two trapezoids equals to the area of the whole shape OASPA, OBQSPA. Okay. So what is the length of line segment ON? From the drawing it is very easy to see. Actually, we already found out. So what is the length of this line segment ON? ON equals to OS minus NS. Again, ON equals to OS minus NS. ON equals to OS minus NS. So ON equals to OS, that is the radius of the quarter circle, that is equal to X, minus SN, that is 6. So we conclusion found out that ON, the length of this line segment ON, is X minus 6. ON equals to X minus 6. Okay. So ON equals to X minus 6 units in its length. And we already found out that the length of this line segment OM is X minus 3. In the next step, we focus on this right triangle ONA. In this right triangle ONA, we define this angle as alpha. So in the right triangle ONA, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha, according to the rule that the sum of the angles in a triangle is equal to 180 degrees. So we defined 90 degrees minus alpha as beta, therefore the missing angle here must be equal to beta. Okay? So if 90 degrees minus alpha equals to beta, it means that 90 degrees minus beta equals to alpha. But if you just add alpha to this equation and subtract beta, we get that 90 degrees minus beta equals to alpha. Then we have here, this is angle AOB, this is equal to 90 degrees according to what is given us the question. So angle AOB is equal to 90 degrees minus this angle alpha must be equal to this missing angle. Again, 90 degrees minus alpha equals to this missing angle. So this missing angle equals to 90 degrees minus alpha, but according to our definition, 90 degrees minus alpha equals to beta. Therefore, the missing angle here equals to beta. So in the right triangle OMB, this angle equals to beta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus beta. But we already found out that 90 degrees minus beta equals to alpha. Therefore, the missing angle here must be equal to alpha. In the next step, here we have line segment OA is the radius of this quarter circle that is equal to x. Why? Because it starts from the center of the quarter circle, that is to say from point O, and ends at point A, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, OA is the radius of this quarter circle that is equal to x. Likewise, OB is also the radius of this quarter circle that is equal to x. So in the next step, we proved that the right triangle ONA is congruent to the right triangle OMB. That those two right triangles congruent to each other. So why those two right triangles congruent to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, those two angles are both equal to alpha, therefore they are equal to each other. And finally, those two angles are both equal to beta, therefore they are equal to each other. And side OA of the right triangle ONA is equal to side OB of the right triangle OBM, they are both the radii of the circle is equal to x, therefore they are equal to each other. In conclusion, we found out that those two right triangles can go into each other according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles in the side that included between those two angles in one triangle are correspondingly equal to two angles in the side that included between the two angles in a second triangle, you actually proved that the two triangles can go into each other according to angle side angle rule. And here we proved that those two angles alpha and beta in right triangle O and A, those two angles alpha and beta, and the side that included between those two angles, that is side OA, in the right triangle O and A, are correspondingly equal to those two angles alpha and beta, and the side that included between those two angles, that is side OB, in the right triangle OBM. Therefore, we actually proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive the side ON in the right triangle ONA is equals to side BM in the right triangle OBM. Repeat again. We derive from the fact that the two right triangles can go into each other, that ON equals to BM. According to the rule that corresponding sides in right triangles are equal to each other. Those two right triangles can go into each other, therefore the two corresponding sides, that is to say ON and BM, must be also equal to each other. But we have already found out that ON equals to x minus 6. So we can write here that ON equals to x minus 6, and from this equation x minus 6 equals to ON equals to BM, we will derive that BM is also equals to x minus 6. Here BM, this side BM equals to x minus 6 units in its length. Likewise, because of the fact that those two right triangles can go into each other, we will conclude that side OM in the right triangle OMB is equals to side AN in the right triangle OAN. Repeat again. We derive that side OM equals to side AN, but we have already found out that OM equals to x minus 3. So we can write here that OM equals to x minus 3, and from this equation x minus 3 equals to OM equals to AN, we will derive that AN also equals to x minus 3. Here AN, side AN equals to x minus 3 units in its length. In the next step, I copied the right triangle AON in a new page and implemented on this right triangle AON the Pythagoras theorem. This is the right triangle AON that I copied from the original domain. ON equals to x minus 6, AN equals to x minus 3, AN equals to x minus 3, and the hypotenuse AO equals to x. It is the radius of the quarter circle. Here by PT is evaluation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse is equals to the sum of the squares of the perpendiculars. So the hypotenuse of the right triangle AON is AO, therefore the square of the hypotenuse is OA square, and it is equals to ON square plus AN square. So OA is x, therefore OA square is x square, and it is equals to ON square. ON is x minus 6, therefore ON square is x minus 6 square, plus AN square. AN is x minus 3, therefore AN square is x minus 3 square. So in conclusion, we found out that x square equals to x minus 6 square plus x minus 3 square. So x square equals to x minus 6 square. X minus 6 square equals to x square plus 6 square, that is 36, minus 2 times x times 6, that is minus 12x, plus x minus 3 square. X minus 3 square equals to x square plus 3 square, that is 9, minus 2 times x times 3, that is minus 6x. So here we have x square on both sides of the equation, so by x square we get cancelled. So in this side of the equation we have nothing, that is to say 0. In the other side of the equation we have 36 plus 9, that is 45, we have minus 12x minus 6x is minus 18x plus x squared. In conclusion, we found out actually that x squared minus 18x plus 45 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, the coefficients a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Now a specific quadratic equation, that is to say, in this equation x squared minus 18x plus 45 equals to 0, the coefficient a equals to 1, the coefficient b equals to minus 18, and the coefficient c equals to 45. Now we have to put this data inside this equation and find out the value of the values of x. So we did it and found out that x equals to minus b. B is minus 18, therefore minus b is minus 18, that is plus 18, plus minus square root of b squared. B is minus 18, so b squared is minus 18 squared, that is 324. Minus 4 times a is 1, times c, that is 45. So minus 4 times 45 is minus 180, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. In conclusion, we found out that x equals to 18 plus minus square root of 324 minus 180 over 2. So x equals to 18 plus minus square root of 324 minus 180 is 143. So inside the root we left only with 143 divided by 2. So x equals to 18 plus minus the square root of 144 is 12 over 2. So here we have two solutions to the possible for x. The first solution for x is that x equals to 18 plus 12 over 2. So 18 plus 12 is 30, and 30 over 2 is 15. So according to the first solution, x equals to 15 units in its length. The radius of the quadrilateral x equals to 15 units in its length. And according to the second solution for x equals to 18 minus 12 over 2. 18 minus 12 is 6, and 6 over 2 is 3. So according to the second solution, x equals to 3 units in its length. But we have already found out that this is line segment BM, that is equal to x minus 6 units in its length. BM equals to x minus 6. BM is a length, and as a length, it must be a positive number. So x minus 6, that is the length of line segment BM, must be a positive number, that is to say it must be greater than 0. If x minus 6 is greater than 0, it means that x is greater than 6. So x must be greater than 6. If x must be greater than 6, if x must be greater than 6, it can never be equal to 3, that is less than 6. Therefore, we cancel this solution and we left only with the other solution that is possible for x, that is that x equals to 15 units in its length. The only solution that is possible for x is that x equals to 15 units in its length. In the next step, I presented to you the area, what is the area of a trapezoid. The quadrilateral ABCD is a trapezoid. Why? Because side AD is parallel to side BC. A trapezoid is a quadrilateral with one pair of parallel sides. Therefore, quadrilateral ABCD is a trapezoid. Those two parallel sides AD and BC are defined as the bases of this trapezoid. And the height to the base is DC. Why? Because it creates 90 degrees with the bases. This angle equals to 90 degrees and this angle equals to 90 degrees. So we define the height DC as h. So the area of this trapezoid ABCD equals to the sum of its bases, that is AD plus BC, times the height, that is h, over 2. So the area of any trapezoid equals to the sum of its bases times the height over 2. So what is the area of this green shape? The area of this green shape equals to the area of the whole shape. The area of the whole shape is the sum of the area of trapezoid OSPA plus trapezoid OBQS. So the area of the whole shape minus the area of this quarter circle OAB equals to the area of the green shape. Repeat again. The area of the green shape equals to the area of the whole shape, that is the sum of the areas of the two trapezoids OAPS plus trapezoid OBQS minus the area of the quarter circle AOB equals to the area of the green shape. What is the area of trapezoid OAPS? The area of trapezoid OAPS equals to the sum of its bases, that is OS plus PA. OS plus PA times the height, that is SP, because it's creates 90 degrees with the bases, over 2. So the area of trapezoid OBQS equals to OS plus AP times SP over 2. OS is 15, AP is 6, SP is 12, divided by 2. 15 plus 6 is 21, times 12 over 2, that is 6, so 21 times 6 is 126. If we're going forward, the area of this trapezoid OAPS is equals to 126 units, 126 square units, plus the area of this trapezoid OBQS. The area of this trapezoid OBQS equals to the sum of its bases, that is OS plus BQ. OS plus BQ times the height, that is QS, times the height, that is QS, over 2. OS is 15, BQ is 6, QS is 12, divided by 2. 15 plus 6 is 21, and 21 times 12 over 2, that is 6, is 126. So the area of trapezoid OAPS is 126, minus the area of trapezoid OBQS, that is OS is 3, BQ, OS is 15, BQ is 3, the height QS is 9, divided by 2. 15 plus 3 is 18, 18 over 2 is 9, and 9 times 9 is 81. In component founded, then the area of trapezoid OBQS, the area of this trapezoid OBQS equals to 81 square units. So the sum of the areas of the two trapezoids is 126 plus 21 plus 81, that is 207. So the area of this whole shape, that is the sum of the areas of the two trapezoids, it is equals to 207 square units, minus the area of the quarter circle AOB. The area of any quarter circle equals to the area of the circle. The radius of the big circle is x, therefore the area is pi x squared, and pi x squared over 4 is the area of the quarter circle AOB. X is 15, so x squared is 15 squared, that is 225, therefore in total the area of the quarter circle AOB equals to 225 pi over 4. 225 pi over 4 is equals to 176.716. Therefore the area of the whole shape, that is 207 square units, minus the area of the quarter circle AOB, that is 176.716 square units, is equals to 30.285 square units. In component founded, the area of this gray shape is equals to 30.285 square units. Okay, thank you very much.